Hey guys, we are going to look at finding the inverse of a log. It's something that's going to help us out later in the chapter as we get closer to the end of the quarter. And it's just basically how you found an inverse before. The steps are, number 1, switch x and y. And number 2, solve for y. An exponential function, though, when you solve for y, instead of really saying solve for y, you may have to rewrite it first. So remember the other day we talked about how you write from log form to exponential form and vice versa. Like when we had log base b of x equals y, that's the same thing as saying b to the y equals x. Remember, the log of a number is an exponent, so this equals right here is your exponent in the exponential form. So you want to remember that little statement as you're doing these. The first one we're going to look at is y equals log of 3x. And we want to find the inverse. Okay? So we're looking for the inverse. Remember the symbol for inverse was to the negative 1 power? So the first thing you do is you switch your x and y. So x equals log of 3y. Now, we need to solve for y right here. But in order to do that, I have to rewrite it into exponential form. So here's my rewrite. My base, it doesn't say the base, so we assume it's 10. We talked about that too, the base common log. If it doesn't say, either base is 10, so it's 10. To the exponent, well, the exponent is right here, x, 10 to the x, equals the number 3y. And now, just simple algebra to solve for y is going to equal 10 to the x over 3. There you go. This is the inverse of log 3 of x, is 10 to the x divided by 3. Let's try another one. Let's try y equals 2e, the number e, raised to the 3x. First step, always the first step to finding y inverse, is to rewrite and switch your x and y. So x equals 2e to the 3y. Now I need to solve for this y here. That's y up in the exponent. So what I need to do is rewrite it into a log form. See, this one, our first example, started as a log form. This one doesn't. So that means I want to write it as a log form. Before I can do that, though, I need to get rid of this 2. And it's just being multiplied. So I'm just going to divide. I'm going to have x over 2 equals e to the 3y. Now I can rewrite it as a log form. Now e is all by itself. So log form is going to say log, my base is e, to the x over 2 equals the exponent, which is 3y. Now there's a couple reasons why I wanted to do this one as an example. First of all, log base e, we talked about that. That's natural log. So instead of saying log base e, because nobody says that, you say natural log of x over 2 equals 3y. And now once again, to solve for y, just divide by 3. So y equals natural log of x over 2 divided by 3. Let's try one more. You might see one like this. Y equals 3 times the quantity 2 to the x. First of all, switch x and y. So x equals 3 times 2 to the y. And before I can rewrite again, just like we did up here, this one's in exponential form, so I need to rewrite it into log form. Eventually I needed this in log form. But before I can do that, I need to get rid of this 3. So I have x divided by 3 equals 2 to the y. Now I'm in strictly exponential form. I'm going to change it to log. So that's going to be the log of base 2 of x over 3 equals y. the log of a number, this is my number, this is my base, the log of a number equals the exponent. That's my exponent. That one's done. That's your answer. That's your inverse. Okay? That's it. And now you need to watch the next video.